Hello guys, it's Dr. AJ. We have today 3 examples about the vertical stresses. Sometimes they are called in situ stresses as well, and they are very common in the FE and the PE exam. So let's get started. So as you can see, this is example 1. It is required to find the total stress for water pressure and effective stress at point A. And point A, it looks like it's on the surface. Gamma drive for the sand, the first layer is given, kilonewton per cubic meter, so please pay attention, it's SI units. Gamma saturated for the sand is given as well, and it's saturated because there is a groundwater table and it starts from depth 5 and goes on. And then it is given gamma saturated for the clay for the last layer. So as usual, we start the solution, we write down what's given. Gamma dry sand, gamma saturated for the sand, and gamma saturated for clay. We have it. We're looking for stresses at point A, at the surface. So what is required? Gamma total, pore water pressure, and effective stress. All of them at A. These total stress, basically, it's density times depth. But what depth? The depth is basically the distance from the surface to the point where you are interested to find the stress at. That's the depth. So in this case, since H on the surface, so H is 0. So as a result, gamma dry for the sand, because basically this is the dry sand layer, times H. H is 0, 15 is the density, so it doesn't matter, it's 0. Second, they're looking for the pore water pressure. So in this case, we're going to be using gamma water times the depth of water. Here we're looking for the depth of water. Gamma water is the density of water, 9.81 in this case, times H. The depth, it is 0, so it'll be 0. Done. Easy. Effective stress is basically the subtraction gamma total minus the pore water pressure. If you subtract the pore water pressure from the total stress, you're going to get the effective stress. What is the effective stress? Basically, the stresses that comes from the soil, purely the soil, on top of the point you're looking to find the stress at. So total stress is 0, pore water pressure is 0, it'll be 0. So in this case, it's C. Example 2 is the same as example 1. Soil profile, gamma dry sand, gamma saturated for the sand, and gamma clay is given. Kilonewton per cubic meter, please, SI units. Now, we're looking to find the stress, the total, pore water pressure, and the effective at point B. This time is different. It's a little bit deeper. 5 meters from the surface. This is point B and this is the surface. And it's just 5 meter difference. So we start with the total stress. This is basically a really simple way to find the vertical stress profile for a soil. So stress is the x-axis and the y-axis is basically the depth of the soil layers. To find the total stress, it's simple. Again, it's density times depth. Density is the dry sand density, 15. Times the depth, 5 meter. What depth? From the surface to the point you are interested to find the stress at. From the surface. So we have 5 meter. So 5 times 15, 75. We're done with the total stress. Now, the second friend is the pore water pressure. We're looking to find the pressure again at 5 meter from the surface. Gamma water, it's 9.81. This is from your FE manual. It is right beneath the saturated unit weight equation. So, gamma water, 9.81. The depth of water, since the groundwater basically at the same level, the depth is 0. So for pore water pressure is 0. The final one is the effective stress. Again, this is the stress, this is the depth. This one is really simple. You do nothing. You find this guy minus this guy, you're gonna get this guy. Total stress, 75. Pore water pressure, 0. 75 minus 0, 75. So in this case, 75 total, 0.75, so it's going to be option A. Example 3, and the final one. So we have the same example, but this time we're trying to find stress at point C. So we start solution again. We write down what it's giving, gamma dry for the sand, saturated, clay, etc. And gamma water again, 9.81. So we start with the total stress. Here I want you to pay attention. Again, extremely simple. The total stress is density times depth. So this is the point C. We're trying to find stress here. So it is basically the stress that comes from this layer plus the stress that comes from the saturated sand layer. And it is total. That means if there is water, if there is oil, if there is rock, whatever, everything on top of the point C, it will be calculated. So the first one from 0 to 5, we put density times depth. This is the stress here. What's the density? It'll be 15. What's the depth? Is 5. Is there anything else? No, just dry sand. Good to go. Now we come here to the point C. We have the gamma dry for the sand because the stress is here. It's the entire thing. If you do just the gamma saturated for the sand times 15, you will find the stresses from here to here only, and this is not right. You see what I'm saying? So what I want you, it's accumulative effect. That's what you need to pay attention to, the total on that point. So from here to here, it's gamma dry times the depth. Since we are trying to find it C, you will use this gamma dry times the depth of the dry sand layer, and then gamma saturated for the saturated sand layer times the depth of that layer, which is 15. Are we gonna add the water? No, we will not add the water because already saturated sand. It already included. So this is basically the total stress at point C. If you do this, you will find the stress at point C. So gamma dry for the sand times the depth of the sand. Gamma saturated for the sand times the depth. So 15 times 5, this is 15, times 5, this depth, plus 20, which is gamma saturated for the sand, for this layer, times 15. You add them, you're gonna get 375 kilonewton per meter square. Stress at point C. So we're done with total stress. Now we're gonna find the pore water pressure. From its name, pore water pressure. So we have to have water, right? First layer, there's nothing. There is no water. So you can ignore it. Water starts from here. So you go, this is from here to here, it's 5, and then from 5, and you add 15, the 20, total 20, because here is the total from here to here, is 20 meter. Here you're gonna see basically the water effect. There's a groundwater table, so we'll start from here. So the depth of water is 15. Gamma water is basically 9.81, and that's gonna give us 147.15 kilonewton per meter squared. So finally, the effective stress. Total stress minus the pore water pressure. This is basically here, the total stress. Gamma dry times the depth, gamma saturated times the depth. We add them together, we're gonna get the total stress at point C minus the pore water pressure. The water starts from here till here, it's 15 times 9.81. We already found this part. We already found this one. We subtract them together, 375 minus 147.15. We're gonna get 227.85. And since the total gamma total 375, 147, that's basically gonna give us option B. This is basically a summary. You can see them all. Soil profile, total stress for water pressure. Start from here. The effective stress, you just subtract this guy from this guy. And this is basically how it looks like in your FE manual. So with that, thank you very much and see you next time.